All right, so as you're aware, there is a technique called integration by parts, as you were aware from your Extension 1 exam, which I will talk about in a bit later, that particular integral, right? But another way they refer to this is like the reverse product rule, so to speak. There's kind of an issue with that, right? So if we take something like this, x cubed ln of x, right? With differentiation, the product rule for differentiation is kind of like a formula in the sense that you can just apply these to any two functions that are there and it will allow you to easily differentiate. Integration typically is a much harder process to do because if you want to integrate this, yeah, there's a lot more to consider, right? And even with integration by parts, as a formula, so to speak, it's a little bit different to your typical formulas. Like quadratic formula, you have like A, B, and C, which are kind of defined values. But from integration by parts, what did you kind of recognize? That's all right. I'll get to the formula in a second. You said something about what was the hardest part.
Like trying to figure out. So I remember the formula. It's like, I forgot what value. Anyway, I'm just going to make up some values.
That's all right.
So U. Yeah. UV. Yeah. Inside of V du. Mm-hmm. Yeah. And
what's the tricky part is?
Tricky part is figuring out which bits U or D. U or V.
Right. So it's not a defined formula in the sense like, product rule is just like U and V and it didn't really matter which one you picked. Or quadratic formula, A, B, and C, they're defined, yeah? With integration by parts, they let you choose U and V and it does actually matter which one you choose in terms of the difficulty for you to actually integrate this. That's why it's not necessarily a formula in the strict sense of things, right? It's kind of like a heuristic approach. Like there's a bit of freedom with it and it's not always a solution that's going to yield the result that you want, right? There are some strategies for picking that. I'll get into that in a moment. But I do want to show you the derivation because the way that we look at it is we consider product rule, right? So we look at product rule, which was the derivative of these two functions here. And that's equal to VU dash plus UV dash, yeah? And so the idea with the derivation of this is that, okay, we're looking at integration. So we want to integrate both sides here. So if I integrate both sides, I'm doing this with respect to x. So I really should be having dx's here. And so this kind of process, these kind of cancel out, right? If you're integrating and differentiating, they're opposite operations. So these will just kind of go away. And what you're going to get left with is uv is equal to the integral of vu dash plus integral of uv dash. And so at this point, it's like, well, kind of what's the goal of this? Well, the goal is to have an expression for an integral of something is equal to like some other expression, right? So really, you could kind of pick either of these and it wouldn't really matter. But by convention, they picked this one to make as the subject, which is going to give us our integration by parts formula, right? So it'd be the integral of uv dash is equal to the integral of, typically they're right, equal to, they make uv over here, and then they put this to the other side, so they take away this here. All right, can you jot that down for me?
I more or less remembered it. I was supposed to.
And so the good thing is on your formula sheet, just be aware though on your formula sheet, what they write is instead of writing v dash, they write dv dx, and for u dash, they write du dx. Okay, so that's just something to be aware of for your formula sheet. So I might make a note of that. So that's the same as dv dx, and that's the same as du dx. So that's kind of the more formal way of writing it, but that will suffice fine for when we're actually doing these problems. Yeah? Okay.